DIY Manual for iCubeSmart GZT64 Canton Tower. Package includes 3mm long pin blue LEDs, 3mm short pin green LEDs, white LEDs, blue LEDs, Type-C cable, remote control, copper post and screw, red and black wire for testing LED, white electric wire, plastic mold for auxiliary welding, welded and tested mainboard. Installation instruction. Before welding, step 1. Please familiarize yourself with the auxiliary welding mold. iCubeSmart GZT64 auxiliary welding mold has 16 loops of different sizes. The GZT64 uses 4 colors of LEDs. The GZT64 has 64 layers from bottom to top. Many layers have the same number of loops. For example, the image above shows its first and second layers, utilizing the 16th loop of the mold and white LEDs. The image above shows its third and fourth layers, utilizing the 15th loop of the mold and white LEDs. For layers 5 and 6, use the 14th loop of the mold and use white LED. For layers 7 and 8, use the 13th loop of the mold and use white LEDs. For layers 64, use the 13th loop of the mold and use green LEDs. For layers 9 and 10, use the 12th loop of the mold and use blue LEDs. For layers 63 and 62, use the 12th loop of the mold and use green LEDs. Proceeding in this manner, covering the number of loops, colors, layers, simply follow the instructions provided in the table. When welding, we recommend grouping in sets of 8 turns, for example, layers 1 through 8 as one group, layers 9 through 16 as another, and so on. Next, let's start soldering. Step 2. Bend LED lamps. The 6-4 layer Canton Tower adopts 64 loops of cathodes and 32 vertical LED anodes. So first, bend the LED short pin cathode by 90 degrees. Please pay special attention to the bending direction of the LED. Please place the 4 different colored lights separately. Step 3. Weld the LEDs. First, install the copper posts onto the mold. Insert LED into the auxiliary mold according to the corresponding relationship between the LED color and the number of loops in Step 1. Following the table in Step 1, solder from the bottom up. Begin by soldering a 16-loop and white LED. Note: let all LED cathodes kept in the inner loop. Then, weld the LED cathode and cathode. Please take care not to short-circuit the cathode and anode during welding. Welding might be slow at first, but once you get the hang of it, it will be much faster. Then, pull out the welded LED loop. Following the table in step 1, solder another 16 loop and white LED, corresponds to the first and second layer of the tower. Next, weld the third and fourth layers of the tower. These correspond to the 15th loop of the mold and the white LEDs. Welding of the 8 loops white LEDs. The 64 loops of LEDs on the tower were welded into 8 groups and then spliced together separately. Step 4. Test the LED loops. Solder the red and black wires to the pads on the mainboard. Connect the mainboard to the 5V USB power adapter. At this time, connect the red wire to the anode LED pin and connect the black wire to the cathode LED pin. The LED will be on. You should test each LED light in this way to ensure that the soldered LED all can be lit. After all LED tests are completed, remove the red and black wires. Step 5. Weld the LED loops. Arrange the LEDs from layer 1 to layer 64 in order according to the table in step 1. Weld the LED anodes in one loop to those in the next loop. Note: take care not to weld the any LED anode to any cathode. The pin tip of the previous LED is welded to the raised part of the pin on the next LED. Weld reliably where LED anodes join. We recommend soldering the two diagonally opposite LEDs first, as this will make alignment easier. Please try to keep the soldering time within 2 seconds, or wear gloves to prevent burning your fingers. After soldering the first and second layers, solder the third layer of LEDs onto the second layer. The 3-layer corresponds to the 15-loop of the mold. Being smaller than the 2-layer 16-loop, it requires extra caution during welding. Soldering the diagonal LEDs first will make it easier to secure the entire ring of LEDs in place. Weld layers 1 to 8 of white LEDs together as a group. Completed soldering 8 sets of 8-loop LEDs. Then, weld the LED anodes in adjacent 2x8 loops together to form 16 loops of LEDs. Weld 2 x8 loops together to form 16 loops of LEDs. Then, weld 2 x16 loops together to form 32 loops. Then, weld 2x32 loops together to form 64 loops. Step 6. Install the tower body to the mainboard. Install the copper standoffs onto the motherboard. Insert the tower body into the motherboard at an angle first. Then, insert the remaining LED pins into the motherboard one by one. Then, adjust the length of the LED pins protruding from the mainboard. The LED only needs to extend 1 mm out of the motherboard. Then weld the pins of the LED lamp anodes. Step 7. Weld the white electric wire between the LED cathode and the mainboard. As shown in the table in Step 1, the first layer, which is the bottom layer, uses a wire to connect to the hole for number 1. The wire is soldered to the cathode of the LED. Then the second layer is welded to the hole marked 2. Then the third layer is welded to the hole marked 3. Proceeding in this manner, solder all 64 wires. When the wire is too long, you can use a clip to secure it, facilitating its precise passage through the tower body. After soldering all the wires, trim off the excess wire. Step 8. Weld the tower top. Bend the short pin cathode of the LED. The first and second loop at the top of the tower use blue long pin LEDs. For the first ring of LEDs at the top of the tower, place one in every other mold hole, utilizing a total of 16 LEDs. After soldering, trim off the excess LED cathode pin. Next, bend the anode pin of the LED 90 degrees. For the second loop at the top of the tower, use long pin blue LEDs as well, placing them every other position. Next, as shown in the video, bend the anode pin of the LED. Weld the anode of the second loop to the anode of the first loop. Then, in the following loops, use short pin LEDs. Soldered 3 loops of 8 white LEDs. Solder the anodes of the 3 white LED loops together with the anode of the blue LED loos. Then, use green LEDs, weld 3x4 LED loops and their anodes together. Then, weld the anode and cathode, respectively, of the 4 green LEDs together. Anodes are welded together. Cathodes are welded together. Then bend the anode pins of the lowest LED. The bent anode is soldered to any one of the 4 LED anodes. The cathode is soldered together with the cathode loop of the 4 LEDs. Then, these 4 green LED anodes were soldered to 8 white LED anodes, one every other LED. Tower top welding completed. Then, weld the anode of the blue LED on the top of the tower to the LED anode of the tower body 64 layer, optionally every other LED. Finally, connect the LED cathode at the top of the tower to the 3 holes marked Tower Top on the mainboard. The negative terminals at the top of the tower can be connected in parallel to form 3 groups. For example, one set of blue LED cathodes, one set of white LED cathodes, and one set of green LED cathodes. The 3 cathode holes at the top of the tower are welded arbitrarily without any order. After the welding is completed, the welding of the entire iCubeSmart GZT64 tower is finished. Plug in a 5V2A power supply to run the built-in animation. The welding methods for GZT64 1 meter and GZT64 plus 1.9 meter are similar. The only difference is the welding mold. Their animation lasts about 7 minutes, after which it repeats in a loop. Due to video length limitations, it will not be shown in its entirety here.